Good day, beautiful people. Hope you all are doing good. It's your favorite sensei here, Sensei Mohau. And on today's lesson, we will be tackling work energy and power past paper question. So on this lesson, I'll be showing you all how to answer questions that specifically require you or want you to find the angle of inclination. Right? So we'll be doing that question. So make sure to like, to share, to subscribe the video, subscribe to the channel, share the video as much as you can, and let's start. A 5 kg block is released from rest from a height of 5 centimeters, slides down to incline. Slides down to the incline P and get as shown below, and then it moves along a frictionless pulley. It moves along a frictionless pulley, and OP and get from a rough surface, then QR is a rough surface. So now they told us the frictional force and get, or there's a non-consecutive force way on QR, which is this portion. But this portion and this portion, they don't have any friction. It's a smooth surface. So when they are saying to us, use energy principles, they want us to only use energy principles to find the speed. So which means that we don't have to use the ones that are v squared, that are the ones from VPM and vertical projectile motion. We don't have to use them. We just only have to use this ones. See, yeah? For the energy engine. So now on number one, how do we do it? Now remember, we are looking from the rest starting position where the block was at 0 meters per second till the place at P. So we're calculating the speed. So we're using just the mechanical energy at A is equals to the mechanical energy at B. Okay? So now the mechanical energy at A, we have 5 kg, get it's 5 kg multiplied by 9.8 multiplied by 5. Remember, 5 is the initial position above the ground, and when it started the movement, and then plus EKA. Remember, they said to us it's at rest, so it will be 0. Then EP for the place at B, it's basically at P. I just wrote B. So we know that the place there, it's 5 times 9.8 times 0. Why 0? Because of it's the ground. So multiply plus half mv squared, and so half mv squared is 2,5 v, and so here we add it, multiplied, it will be equals to 98. So we divide both sides by 2,5, and then we'll get 39,2. Then we square root the answer to get the velocity at P. So now that is our answer. Answer will be 9,9 meters per second. So they are saying to us that PQ, okay. So explain why the kinetic energy at P is the same as the kinetic energy at Q. So now kinetic energy, why is it the same? It's because of, remember, first thing, it may be because of there's no friction between P and Q. Secondly, the mechanical energy is always conserved. So which means now if the kinetic energy is the same, it means that the speed there from this point A, P to Q, it's the same speed. So we know that basically the speed at Q will be equals to 9,90. So the answer will be the mechanical energy is conserved, and then there's no friction. So now question 3, they're asking, what is the term of a non-consecutive force? Remember, let's recap. A non-consecutive force, it's more similar to like a non-contact force. It's a force that takes place without any interference, or it doesn't basically it's a force that doesn't need to have contact on the object. And it's a force like, for example, gravitational force, electrostatic force, magnetic force, and yet they don't really need to touch the object for the force to be acted upon it. For example, a magnet, we can put maybe a metal surface here or any metal object and a magnet here. We know that basically the magnet will attract or cause that force of attraction. It's an example of a non-consecutive force. It's the force that will be exerted on the object without any contact. Okay? So it's basically like that. Ne? So now go 2.3.4. They're asking us to find the angle theta, this angle. Now remember, basically this thing makes up a right angle triangle. And so since it makes up a right angle triangle, what happens? And we know that this QR is the hypotenuse side, this 3 is the adjacent, so the opposite side, and this is the adjacent side. Ne? This is the opposite side, there 3. So now, for us to find that, we have to find QR, and so that we can use either the trig ratios. And here, unfortunately, we cannot use theorem of Pythagoras because of we don't also have the side A at the adjacent side. So we have to find QR or A. Ne? So now, how can we do this? Ne? Now, we can either try to find the work done, ne? The total work done or the net work done by non-consecutive force. And so now we can find the work done by non-consecutive. Remember, how can we do this? And remember, if we want to solve for this, and we have to use the work done. Why? Because in the formula of work done, we have delta x, and which shows the displacement. And so which means we'll be able to find this displacement here. So but unfortunately we don't know the speed, but and generally we know that P and Q, the kinetic energy is the same, so which means so the speed at P and the speed at Q is the same, and they told us that it will come to a stop at R. And so which means so we already know, oh, here it's 9.9 and here it's 0, the speed. So which means we can try to use the work net equals to the change in kinetic energy, and we already know the kinetic energy at that place. So now we can either do it like this. So I'm just showing you the first thing that I did. So it's work net is equals to delta EK. And so our EK will be from point Q and point R. And so at point Q, we know that our delta EK, it's more or less the same thing. And because of we know it's half mv and squared. And so we know that the velocity is 9.9. So basically it's something like this, and then we know that delta EK get that thing. And so now we have to have or find the work done. And so we have now here the we have frictional force and acting on the place. And remember, if we try to do a free body diagram of this, when it's going up, and when it's going up here, going up, first of all, it doesn't have applied force. It's going up due to that momentum caused by gravity when it was Netelham. Netelham, remember, it went down due to gravity. And then it had the same momentum, same speed. So now, which means it doesn't have force applied, and yet it only has frictional force and Fg parallel. And so Fg parallel, remember, it's always acting downwards, and yet in the opposite direction of motion. And so now and then frictional force. And although we know that it's going up there, but force of gravity, it's opposing the motion, and Fg parallel, it's opposing the motion also, because of it's not going up, it's going down. Ne? So now work net by the frictional force is F delta x times cos 180, because of it's in the opposite direction of motion. Then we will find negative 18x, then delta work done by the gravitational force, it will be mg sine theta. Remember, for the parallel one, it's always mg sine theta. Remember, the theta is the theta here, so it will be mg sine theta, then multiplied by the delta x of the displacement and the cos. So although here we have two unknowns, which is the theta L and the displacement L. So now basically we can now change this, this sine x, in a form of this delta x. Now remember, this is a triangle, right angle triangle. So we know that here this will be the opposite side and this will be the hypotenuse side. So sine theta is 3 over this displacement on QR, which is the unknown one. So instead of us saying sine theta, the reason why I'm removing the sine theta is because we don't know this angle. So the only best way for us to find the angle is to firstly find this displacement on QR. So I'm just substituting where there's sine theta, I'm just putting the opposite, which is 3 over the delta x that we are looking for. Hence why it's like this. So basically this and this will cancel out, and then we'll be left with 49 times 3, which is equals to 147. So now we know basically the work net is basically more, remember, when we're doing a work net, similar to us doing the resultant force. So both of them are in the same direction, so they'll be just adding together, same direction. So it's negative 18x plus 147. Unfortunately, they are not like terms, so we cannot add them any further. We just leave them like that. So that's the answer that we inputted here. And then negative x, so here basically simplified, here it will be this simplified will be negative 245, 0.25, and here it's 2 times 0, then 2 times 9.9, and here, which gives us negative 245, 0.25. So now remember, we are solving for x, so we take 147 to the other side, it becomes a positive, then draw about negative 140, negative 18 is equals to negative 245 plus 147, and then the answer will give us basically, after finding the answer, we divide that answer by negative 18, which there will give us 5,4458 meters. So I'm not rounding it off to 2 decimals because of we are not yet done with the answer. So now after that, for us to find the angle, and you remember here, we remember sine theta, it was equals to 3 over m. So we already found the m, which is like the delta x here, and so it is now, we substitute it, and then for us to find the angle, remember we do shift of sine, which is shift of 3 over 5,4458, then the answer will give us 39,43, which will be our angle. So this is the it was the last question that we were supposed to do.